data. Presentation of data is mainly classified into three main stages. The first is to arrange the data systematically or in an organized manner, where the particular researcher or individual organize the raw material into a logical order and remove the confusion or making it more readable to the readers. The next and the second stage is to summarize the information. Once the researcher or individual organize the raw data into organized manner, then the next stage is to condense the large amount of data into a shorter or a meaningful format in form of tabulation and any other part of rows and columns, which highlights the key findings that what exactly the exact raw data when it organized in the when it organized way, what sort of outcome that has been came up. Tables and diagrams. It also is the presentation is also helps to analyze and interpret the data, and of course at the end this presentation of data which also supports a decision making toward where the number of students has also been shown in along with respective genders, that the boys are 60 and the girls are 40. So when we represent that any sort of data, the rectangular bars of the equal width, the length and the height of each bar represent the exact value or a certain value of a data. Bar could be a vertical, that is a column chart, and it could be the horizontal bar chart. A few features of this type of graph could be the bars are separated by the equal spaces. It may be used for the characterial or the discrete data, and it would be very easy to compare the different groups when it represented in the form of graph. So this is one of the example of the bar graph or a bar diagram, that in a firm of 400 employees, the percentage of a monthly salary by each 1110 would come. A histogram is also one of the type of bar which is used for the continuous data, and it shows the frequency distribution. That means the continuous frequency distribution. A few features of histogram would be there are no gaps between the bars. It represents the class intervals, that is through the ranges of series like 0 to 10, 10 to 20, 20 to 30 and so on. And the area of the bar represents the frequency. That means 0 to 10 and the 5 frequency cover comes under 0 to 10 marks. 8 frequency comes under 10 to 20. That means this is the area of the bar which represents the frequency which comes under the class intervals. This is one of the example of the histogram that present the following information in the form of histogram. The marks is already given 0 to 10, 10 to 20 until 40 to 50, and the number of students are also given, that is 16 to 28. So let's have a view that how the histogram is to be drawn in the next slide. So this is how, when this is also a rectangular, or you can say of bars, but there is no gap between the rectangular bars, which as if I compared to the bar graphs. So histogram of equal intervals where there is no gap between that intervals. So if we talk about 0 to 10, then again the another you can say graph bars has to be drawn, rectangular bars has to be drawn, that is 10 to 20, then 20 to 30, that is of equal intervals, which where the gap of the between the bars does not exist in case of the histogram. So you can also draw or coloring to the rectangulars of bars of equal intervals. So this is how it could be drawn, that based where the marks has been measured on x-axis and the number of students measured on y-axis. So based on the marks, the frequencies has to be drawn in the form of equal intervals or in the form of rectangular bars of equal intervals. What are the uses of histogram? It shows the continuous data series or in the form of distribution of marks. It is mainly also used for the income distribution, age distribution, or the socio-demographic variables. The histogram would be used in such a way. Advantages of histogram: it shows the shape of distribution and useful in mainly statistics, descriptive statistics. The next form or the next visual tool is a frequency polygon. Frequency polygon is a graph which is obtained by joining the midpoints of the top of histogram bars using a straight lines, and that is called the frequency polygon. So when the midpoints, when a particular individual is joining the midpoints of the histogram, of the top bars of the histograms using straight lines, that is exactly called the frequency polygon. And this type of diagram will also be drawn along with the histogram or without the histogram as well. The few features of this type of graph would be the x-axis, where we refer the class intervals, or in other words the midpoint of the class intervals. The next is a y-axis, which refers of frequencies, and the points are connected at the top of the midpoints of the histograms, which could be drawn by the straight lines, and that is exactly called the frequency polygon. So one of the example which you will get an idea that how to construct the frequency polygon for this particular, using this particular data. The following data shows the number of shops on 70 streets in a city. Construct a frequency polygon from the same. So number of shops, that is 1 to 6, and number of street, that is 80, 40, 25, 9, 8 and 6, and the grand total of the frequency or the number of street, that is 70. So let's have a view. This is how the frequency polygon has been drawn. The frequency polygon showing the number of shops in street. So if you look up, the number of shops has been measured on the x-axis and the number of street measures on the y-axis, and based on the number of shops, the number of streets has been drawn. Begins from 0 to 8, then for 1 that is could be 14, on 3 it could be 25. So accordingly you just mark the points, and once you mark the points of all of the 7 shops, then and accordingly you just draw the straight line of by connecting. That is exactly called frequency polygon. Lower class limit. Lower class limit. So when we talk about lower class limit, let's say marks would be, so when we talk about lower class limit, let's say marks would be 10 to 20. So 10 would be the lower limit, and you can say 20 would be the higher limit. So it shows that cumulative frequency values could be greater or equal to the lower limit. That means it should be more than 10. That could be more than cumulative frequencies. How to draw x-axis would refers to a lower class limit like 0, 10, 20, 30 and so on. And the y-axis would be the cumulative frequency. It could be 40, it could be 35, it could be any value, any certain value. And when we plot the points and join them, that could refer to a more than cumulative frequency curve. And this curve, when we talk about the shape of the more than cumulative curve, it slopes downwards from left to right. So let's have an overview with the help of the example that how to draw the more than cumulative frequency curve. One, more than. If you look up the example, it could be more than. We'll refer the lower limits, that is more than 1, more than 11, more than 21, more than 31 and so on. And same which has been referred in the frequency table. that is more than 1, more than 11, 21, until more than 71. The frequencies is already written, that is 3, 8, 12, which is given in the question, 14, 10, 6, 5 and 2. And more than cumulative frequency would be, first we refer the total of frequency, that is 60, and one by one. In case of the more than cumulative frequency, we just deduct from the frequency, we deduct the value from the respective frequency. But when we talk about the less than or cumulative frequency, we just add the frequencies. So when we talk about the more than cumulative frequencies, we just subtract from the total frequency. So the total frequency is 60. So 60 minus 3, 57. 57 minus 8, 49. 49 minus 12 is 37. 37 minus 14, that is 23. 23 minus 10, that is 13. 13 minus 6, that is 7. 7 minus 5, that is 2. That means the and marks of the frequency, that is 2, and the ending frequency of the more than cumulative frequency, that is also 2. It should be the same. If it is not same, that means some calculation mistake or some conceptual adding or error would be there. So it would be good to verify if you have having the same frequencies at the end of the more than cumulative frequency table. That means your calculation is correct and has been verified by having the same digits. So that is called the more than cumulative frequency tables, and based on this is shown in the diagram, that's called the more than cumulative frequency curve, right? So this is how you could draw. The next concept is a less than or give curve. It shows the cumulative frequencies of values which is less than or equal to the upper class limit. So when we talk about more than, it is a lower class limit, but when we talk about less than, it is the upper class limit. So it is how to draw. We can just have a two axis, x-axis and y-axis. X-axis we refer to a upper class limits, that is 10 to 50. For example, then y-axis, that is cumulative frequency 5, 13 and so on, just for the sake of based on the assumed values. So plot the points, joining them with a smooth curve, that's called less than or give curve, and the less than or give curve always slopes the upward from left to right. So this is an example that construct a less than or give curve using the following data. The classes or the class interval is already shown in the table, that is 10 to 20 till 60 to 70, and the frequency is also shown from 2 till 3. So this is a less than or give cumulative table. So the class is already given 10 to 20 and 60 to 70. Frequency is already given 2, 5, 9, 14, 7 and 3. Lower limit is already shown here, that is 10 to 20, 30, so on. And the cumulative frequency is just the adding of the frequencies, that is from 2, 2 plus 5, that is 7, 7 plus 9, 16, 16 plus 40, 30, 30 plus 7, 37, 37 plus 3, 40. That means the total of frequency would be 40, that, and the cumulative frequency at the end of the value is also should be 40, or should be equal. And that is exactly called the less than cumulative frequency table, and based on this table we just easily draw the less than or give curve, which begins from lower value and reaches to the highest value, which refers to a upward smooth curve. So this is how the less than curve has been drawn, that is 0, 10, 20, 30, 40 and so on, and the values of y-axis has also been shown, and accordingly we just mark 10 to when there is a The intervals, that is upper limit value is 10, the frequency is tool. Upper value is 20, the frequency is 7. 30 is 16, 40 is 30, 50 is 37, and the last is 60, that is 40. So this is how that begin from the lower frequency to the highest frequency, that is exactly called the less than or give cumulative curve. Now we can come up to the next concept, that is called the central tendency. Central tendency is one of the statistical measure which identifies the center or the typical value of a data set. Or in other words, we could also say it shows the value around which the data is more concentrated. So when we collect the large amount of data, central tendencies always helps to summarize into one representative value of one central value of a data set, that is exactly called the central tendency. Importance of the central tendency. It simplifies the large data. It makes comparison more better or more easier to the readers or to the individuals. It also helps to prepare a meaningful decision in the businesses or industries. It also used in economics, business research, and statistics as well. So these are the three main measures of central tendency, that is mean, median, and mode. So let's have an overview of these three main measures of central tendency. First is mean. What is mean? The mean represents the average value of the data set. It is mainly calculate the sum of all the values divided by the number of value or a total observation, and the step is divide the number of observation, that is 5 values. So mean is 5, divide by 5, 50 divided by 5, it equals to 10. That means mean is 10. Let's talk about the mean of discrete frequency or data. So when data is given with the frequency, that means mean, that is x bar is equal to sigma x by sigma fx, where the f is a frequency, x is a value, and sigma f is a total frequency. So with the use of this formula, we can easily calculate the mean in case of discrete data. So this is an example where the mean marks has been given 10, 20, 30, and frequencies also calculate the mean, that is you can say sigma fx by sigma f, that could be the mean. This is how the mean is to be calculated in case of a discrete series, and the 230 is a fx and the sigma f, that is 10. So 230 divided by 10, we can easily calculate the value of mean, that is equal to 23. The next part is a mean of continuous data, we can call a grouped data. Steps would be there to find out, first to find out the class midpoints, that is M, then multiply the midpoint by frequency, that called Fm, and use the formula, that is x bar is equal to sigma f by sigma m. That means the sigma Fm by sigma f. So this is an example which refers a direct method to calculate the mean. Income is already shown, that is 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60, and so on. Number of persons, that is 4, 7, 16, 20, 15, and 8. The solution income is 10 to 20 till 60 to 70. Then the first step is to calculate the mid value. So mid value, how to calculate? That is the lower limit plus upper limit by 2. So 10 plus 20 by 2, it's 15. 20 plus 30 by 2, 25. 30 plus 40 by 2, 35. 40 plus 50 by 2, 45, and so on. The number of person frequency is already given to you, that is 4, 7, 16, 20, 15, and 8. And the next step is to calculate the FM, because the formula of mean shows a sigma FM by sigma F or N. So the N is, or sigma F is 70, but we need to calculate the sigma FM. F is already given, M is already calculated. So 4 into 15, 60. 25 into 7, that is 175. 35 into 16, that is 560. 45 into 20, that is 900. 55 into 15, that is 825. 65 into 8, that is 520. So once we multiply the frequency into midpoint one by one, we can easily calculate individually FM values. So once we calculated all the FM value, F into M, that means equal to FM. So sigma FM, the value we can easily, by adding up all the values of FM column, it reaches to 3040. So that means sigma FM is equal to 3040 by N, that is, or by sigma F, that is 70, which is equal to the 43.43. So this is the value of mean. And the formula to calculate the mean in case of the continuous series, that is the sigma FM by sigma F rather than sigma F by sigma FM. So it's a typing error could be possible. The next concept is median. So median refers a middle value of the data set in which the data set is arranged either in the in ascending order or descending order. So median is a middle value of the data set that could be arranged in the 13, 12, 10, 9, 7, 5, 2. So these are the values which has been given in case of the median. So once we talk about the how many number of 40, 38, 35, 33, 32, 30, 29, 30, 27, and so on. So this we have an even value of 14 digits: 3, 3, 6, 7, 8, 9, 10, 11, 14. A number of observations. So total number of observation is 14. Value is even said. So what would be the central value? That is 29 and 27. So once we add these two values divided by 2, it does not contain any mode at all. So it doesn't mean that the mode cannot be calculated. It could be calculated. So consider the given data set, that is 5, 4, 2, 3, 2, 1, 5, 4, 5. This is the values that we have to calculate the mode. So 5 comes 3 times. The 5 is a mode. So this is a case of a discrete data. Find the mode for a given discrete series, and the variable is already given: 5, 10, 15, 20, 25. Frequency is also given: 4, 2, 6, 8, 3. So it is visible that the variable 20 has a highest frequency value of 8, hence the mode is equal to 20. If you look up the frequency, 8 would be the highest value and the respective variable value is 20. That means 20 is a mode. So how to calculate the mode in case of continuous series, in case of continuous data? That is MO, that is a symbol of mode, that is equal to the L1, that is lower limit of the model class, plus F1, that is a frequency of a model class, F0, that is the frequency of class preceding the model class, that is F2, that is the frequency of the class succeeding the model class, and I is a class interval of the model class. So this is a formula of the continuous series to calculate the value of mode. So this is an example of the continuous series that find out the mode of the following series. The class interval is 0 to 10, 10 to 20, 20 to 30 and 40 to 50, and the frequency is also given in the question, that is 7, 10, 15, 8 and 9. So let's have an overview to calculate the value of mode using this data. So the data shows the class interval, that is 0 to 10 till 40 to 50. Frequency is also given, that is 7, 10, 15, 8 and 9. So based on the formula, we need to calculate the F1, F0 and F2. So when we talk about F1, F1 stands the highest frequency. What is the highest frequency? That is 15. That is F1. F0, the frequency which is preceding the highest frequency. So the 10 would be F0. What is F2? The frequency which is succeeding the highest frequency. So highest frequency is 15. Succeeding, that is just below, that is 8. So F2 is the 8. I repeat once again. F1 is the highest frequency, that is 15. F0, the frequency which preceding the highest frequency, that is 10. F2, the frequency which succeeding the highest frequency, that is 8. So F1, F0 and F2, the value is already shown, that is lower limit that could be considered highest frequency is 15 and with their respective class interval is 20 to 30. So 20 is a lower limit. What is the class interval that we have got it? That is 20 to 30, and what is the difference of that class interval is 10. So I is equal to 10. So 20 is lower limit, F1 is the highest frequency 15, F2 is the frequency of succeeding the highest frequency, that is 8, F0 is preceding the highest frequency, that is 10. And I is a difference, that is 20 to 30, that is also 10. So once we got all the values, when we estimated all the values, we just put the values into the formula, that is mode lower limit plus F1 minus F0 by 2F1 minus F0 minus F2 into I. So 20 plus 15 minus 10 by 2 into 15 minus 10 minus 8 into 100 into 10. So 20 plus 15 minus 10 is 5. 15 into 2 is 30 minus 18, because 10 plus 8, that means minus 10 minus 8, it becomes minus 18. Why? Because minus value, minus 10 is a higher value, so minus 18 would be there into 10. So mode is equal to 20 plus 50, you can say 50. 5 into 10 is 50 and 30 minus 18 is 12. So 50 by 12. So 20, once we divide 50 by 12, we got 4.16. So 20 plus 4.16, we can easily calculate the mode, that is 24.16. And the mode has been estimated using this formula, that is 24.16. So this is a way to calculate the value of mode. The next concept is a geometric mean. So in mathematics, the geometric mean is the average value or the mean value which reflects the central tendency of the set of values by finding the product of their values. So when we do a product of all the values, then we can easily get the geometric mean. So we multiply the value numbers all together and take the n root of the multiplied numbers, which where the n is the total number of data values. For example, for a given set of two numbers such as 3 and 1, the geometric mean is equal to root 3 into 1, that means root 3, and what was the root 3 value is 1.732. You can also use the normal calculator and can easily calculate this root of 3. You can easily get the 1.732. So this is a formula of geometric mean. GM is a geometric mean which is equal to x1, the value of value 1 into value 2 into value of n items, and just make out the root. That is, there are two values, that means square root, 3 value, cube root, and so on. So this is how we can calculate the geometric mean. So given numbers are 4, 16. So geometric mean of 4 and 16 root, we can just take under root of 4 and 4 into 16. 64 we got the new value, and we just do a square root. Why? Because there are two values. So square root of 64, that is 8. So geometric mean of 4 and 16 is 8. So this is a difference between the arithmetic mean and geometric mean. Arithmetic mean is a measure of central tendency, and it could be found once we add up or adding all the values of the data set and dividing by the total number of values. Geometric mean is also the measure of the central tendency, but it's calculated first taking the product of the n number of values and then calculate the root of that value. 7 would be the arithmetic mean, because we can also call the another name that is called arithmetic mean. Find the geometric mean of 4, 6, 10 or 8. So once we just multiply all the 4 values and we just make up a square root, and that is could be 6 point. Harmonic mean for data 2, 5, 7 and 9. So the given data is 2, 5, 7, 9. First step 1, find the reciprocal of the value. So once we do the reciprocal, 1 by 2, 1 by 5, 1 by 7, 1 by 9, we receive the reciprocal values of the data set, that is 0.5, 0.2, 14.14, 0.11. That's step 2. Calculate values obtained from step 1. So once we add, the total number of data values is 4, that is 0.954. So automatically once we calculate the harmonic mean, that is 1 by average. So once we calculate 1 by average, we can easily get the harmonic mean value, that is 4.19. So the harmonic mean for the data, that is 2579, is 4.19. So calculate the harmonic mean for the following data in case of discrete series. So that means 5, once we divide the 42 by 7.879, we can easily get 5.331, and that is exactly called harmonic. If you and that is exactly called harmonic. If you look up in the previous question, as we need to calculate that is n. Harmonic mean is n by average. That means n is 4 and average is 0.953. So once we divide 4 by an average, we can easily get the 4.19. So this is how we need to calculate the harmonic mean in case of a discrete series. This is a table, and with a discrete series, this is a table, and with the use of this table, we have estimated the harmonic mean. That is the next concept is the skewness. Skewness is a valuable skewness. Skewness is a valuable statistical measure because it provides an insight measure because it provides an insight the shape that what would be the shape and the nature of the data set distribution. For example, understanding whether a data set is positive or negative skewed can be important in the various fields, including finance, economics, or a data set mean value as well. A negative skewed distribution is one with a tail on the left side. When the positive, we always talk about the right side of the tail, and the negative, we always talk about the left side. So if you look up the shape of the skewness symmetric distribution, so this is a line which is the central one, that is called the median. And when you look up of the median on the left hand side, right, so we always talk about the negative skewness, and when we talk about the right hand side, we always talk about the positive skewness. So this is how we distinguish the shape of the symmetrical distribution, where the center line would be the median, where the left side of the central line of the curve shows a negative skewness and the right would show a positive skewness. This is how that we show through the diagram as well, that the values which is on the left side, which is a negative skewness, the values which is in the right side shows a positive skewness. This is how there are measurement tools or the measurements of skewness. The first one is a Karl Pearson measure. When we talk about the Karl Pearson measure of skewness, it uses the mean, median, and standard deviation of a given data set, and to mainly to identify the shape of the data set, whether asymmetric or the symmetric. So it always shows or provide a valuable insight into a shape of the data set distribution, because ultimately the skewness always reflect the shape and the nature of the data set of the distribution. And that's why under the Karl Pearson measure, which is equals to the mean minus mode. So this measure is more valuable in the various field of statistics and data analysis, which helps the researcher and the analyst to understand the direction and the degree of skewness in their data sets, which always inform a meaningful information, and that could be used through the statistical tools like modeling or a mathematical models, which always inform a subsequent modeling and the analytical decisions. So this is how to calculate the Pearson median skewness of the number of sunspots observed per year. Mean is given 48.6, median is given 39, standard deviation is given 39.5. How to calculate the Pearson median skewness, that is 3 into median minus mode by standard deviation. So the Pearson median skewness is 3 into 48.6 minus 39 by 39.5, and we can easily calculate the Karl Pearson measure value in case of median, that is 0.73. So this is how we use the formula and to calculate the value of you can see Karl Pearson median. The next concept is the Borley measure. Borley skewness coefficient measure is being named after the British economist, that is Arthur Leon Borley, who has developed a statistical measure which is mainly used to assess the skewness or assess the skewness, whether symmetry or asymmetry in the probability distribution. It totally depends on the movements, that how the changes which occurred from the mean values, and this particular measure is totally based on the quartiles. that is Q1, Q2, Q3, and so on. So coefficient provides a simple way to understand the direction and the magnitude of the skewness in the data set. So this measure reflects the direction and the magnitude of the data set, and it is also called a robust measure of skewness. Coefficient of Borley measure where the b is equal to 0, where the beta is equal to 0, that means the distribution is perfectly symmetric about the mean, that is no skewness. When the beta value is less than 0, that means the distribution is negatively skewed. So when we negatively skewed, which always talk about the left skewed, that means tail on the left side of the distribution is longer or heavier. When the beta value, that is b, is greater than 0, that means the distribution is positively skewed or a right skewed, which indicate the tail on the right side of the distribution is longer or heavier. So b is a Borley measure value or a beta value, and that is if it is equal to 0, no skewness. If it is less than 0, negative skewed. Which it is more than 0 is positive skewed. So this is a difference between the dispersion and skewness. So the first one is focus. It mainly focus on the variability or that how the data has been you can say calculated based on the points around the central tendencies. But skewness is always focus about the shape and the nature of or the direction of the data set of the distribution. Measurement. The common measures of dispersion include the variance, standard deviation, range, interquartile range. But skewness is always have a common measures like Carl Pearson coefficient of skewness, moment skewness, graphical methods like Q-Q plots. Relationship to mean. Dispersion measures are not directly to the value of mean because they affect the mean interpretations when it is used as a measure of central tendency in case of dispersion. But skewness provides information about the relationship between the mean, median, and mode as well. So positive skewness implies the mean if greater than the median, or negative if negative skewness when the mean is less than the median, and that is why the skewness is reflects the you can say the shape and the direction or the magnitude of the skewness based on the measures of the central tendencies like mean, median, and mode and standard deviation. And whereas dispersion measures are not directly related to the mean and median, because as it is mainly used, because in case of dispersion mean is mainly used as a one of the measure of the central tendency in order to calculate the standard deviation, mean deviation, and or average deviation, etc., or the coefficient of variation. And based on mean we calculate all of these deviations, that how the magnitude of the data set is changed of the distribution. So this is how we can distinguish between the dispersion and skewness. The next is the interpretation. A high dispersion indicates that the data points are scattered and dispersed, but positive skewness is a right skewed distribution, and negative skewness is a left you can say skewed distribution. Application. Distribution measures is always aims to understand the variability of the data and how to access of the you can say loosely data points. But skewness is always tell us the shape of the distribution and identify whether it's skewed to the left or right. If few examples would be the variability of the stock prices in case of dispersion, and skewness would be the income distribution, often left skewed or right skewed. It respond or another example could be responses on the website also. That's all for today. Thank you so much for listening this lecture. I will come up to a more interesting, relevant, important topics in the upcoming session. Till time, thank you and namaste to all.